So in this video we'll see about a D latch, or it is also called as a transparent latch, and also we'll see why it is called as a D latch. So before I go to the explanation, let us see how the D latch is made. In the previous video we have explained this SR latch with control input. Now let us draw the same thing and we'll discuss how the D latch is made. So in SR latch what we have this AND gate. I am just drawing the SR latch again. So here there will be the feedbacks from the opposite side, and the input S, input R, and with a enable pin or the control pin. So this was the SR latch. So what change has been made here? Instead of having two different inputs, so what change is made is the same input is given to the other NAND gate with a NOT gate. So this is the only change have been happened, and this is the circuit is been given here. Now how does this circuit works? Let's see. So let me just wipe this out, how this is made. So in this circuit there are two conditions only. So what are the conditions? Either the enable pin is equals to 0 or either the enable pin is equals to 1. Now in our previous video we have already discussed, if the enable pin is equals to 0, then there will be no change in the output. So this remains same, whatever the input configuration remains. If the enable pin is equals to 0, then the output will be no change will happen in the output. So basically it will be in the memory state. So we'll check the other conditions. When enable pin is equals to 1, then what happens to the output? Now because there is a single input and it is given to one of the NAND gate as it is, and it is given to one of the NAND gate with a NOT gate. Now let us consider the value of D is given as equals to 0. Now what condition we have? We have case 1 where enable pin is given as 1 and D is given as 0. In this case what happens? Okay, now whenever this D value is equals to 1, that means this NAND gate gate is receiving the value as 0, and the below NAND gate is receiving the value as 1 because of this NOT gate. Okay, now if we compare the scenario with the SR latch, now let us see the SR latch here. Okay, so in SR latch, now what is the scenario? Here the value is 0 and here the value is 1. So we can see in SR latch, if the value is 0 and 1, then the Q is in the reset state. Okay, that means if D is equals to 0, so this is what happens. So basically I can write here S and R. So that is what happens. So 0 and 1, so value of Q will be 0 and Q dash will be 1. So Q will be in the reset state. So what happens? When the value of D is equals to 0, Q is equals to 0. So that is in the reset state. Similarly in case 2, when enable pin is equals to 1 and D value is equals to 1, both are equals to 1. So what will happen with the inputs? Let's see. So now this D value is equals to 1, and because of the NOT gate, here value received will be 0, but internally it is just a, if I separately write this is a SR latch. Now that also we have discussed, if S is equals to 1 and R is equals to 0, then Q is equals to 1, or it is in the reset state. So I am not explaining that how this is going to be reset or set in the, if the S and R value are changing. So you can refer to the previous video. So that means in this case Q will be equals to 1 and it is called as set state. Okay, now let us see why the name is called as D latch or transparent latch. So D latch means basically it refers to data latch. So data latch means what? So whatever the input I am giving, now if you see here, if D is equals to 0, then the output Q is 0. If D is equals to 1, then the output Q is also equals to 1. So what happens? Whatever the input data I am giving, the same is getting stored in the flip-flop or the latch. So this is why it is called as a data latch. That means if D is equals to 0, Q is equals to 0, or if D is equals to 1, then Q is equals to 1. So that's why it is called as a data latch. So it will store the same value that is given as a input. If I need just a storage device, then D latch is the best thing to use, because I don't have to give two inputs here. And one more advantage is there. If you look at the SR latch, so there is a state where both the value becomes 1. Becomes a indeterminate state. That means the state is invalid, that should not be taken. But if I use a D latch, so I have only one choice of giving the input. Either I'll give it 0 or I'll give it 1. And every time these two inputs these two inputs will be different, because there is a not gate in between. So the case of both inputs to the NAND gate is one avoided. So by default, if I use a D latch, then this case is avoided. The undefined or indeterminate state is avoided in D latch. Okay. So D latch has an advantage like this, that it avoids the same input condition, and also it is called as a D latch because it transfers the data that is available in the input to the latch. Now why it is called transparent? But the name is basically same, because whatever the input is there, the output is going to be same, or the D latch or the latch is going to store the same data. So that is why also it is called as a transparent latch. Now next thing is, in D latch there is one more case, that when it will be behaving as a memory. So that is also a question, when it will behave as a memory. Because if you see in SR latch, there is a condition 0 0. If the both the inputs are equals to 0, then there will be no change, or it will be in the memory state. Now the question is, in D latch, where does that happen? So by default, if enable pin is equals to 0, then it is in the memory state. If I want to use the latch in the memory state, or no change should happen, then I can make enable pin equals to 0. Or if I want to store any data, I can make the enable pin is equals to 1, and I can change the value of D. So that's why you can say, when enable is 0, it is in the memory state, and when its enable pin equals to 1, it is in the active state. That means it will store data. It will store data when enable pin is equals to 1. So that's how D latch works. So in the next video, we'll come across another latch. Please see the next video. Thank you.